Okay, we're going to solve rational equations and inequalities. We're going to have to move quickly, so try to hold your questions unless it's just dire until we get to the end of each example. Okay, so solving rational equations, the first thing you want to do is find the excluded values. The excluded values are those which will make your denominator 0 undefined. This is where this ties into what we've been doing already. Excluded values are also going to go with your LCD. So the next step would be to find your LCD. Once you find your LCD, you're going to multiply both sides by your LCD. Does anybody know why we do that? Why would you multiply both sides of an equation or a fraction by an LCD? What does that do for us? Very good fragment of a sentence. Finds a. Okay. That was very positive, though. See how I said very good? Anybody else? What do we do? Why would we multiply by LCD?
No, great common something.
Least common denominator.
Okay, what do we not like?
Fraction.
We don't like fractions, so what does multiplying through LCD do? Cancels the fraction out. Essentially, you'll see, we're going to get rid of the fraction. Okay? Because remember, we're talking about rational expressions, meaning you're going to have x plus something. So if you remember getting the LCD from the first couple units, it was taking all the different ones, right, and multiplying them together. You'll see that in just a second. Okay? Number 3 is multiply both sides. I already said that one. Number 4 is simplify and solve the resulting equation. If you do this right, it's going to break down into a linear equation in which you just solve for the variable, or it's going to break down into a quadratic equation in which you would just factor and solve for the variable. Then you check your work. Good times.
Sure.
Any questions? Okay, I'm going to need you to scroll because I don't know what the deal is with the computer that it's not working. So keep going. All the way up to the top. All right. Good deal. Okay, so here's our first example. We're going to do s plus 5 is equal to 6 divided by s. So the first thing we want to do is find the excluded values. Okay, what is going to create an undefined scenario here?
0.
Yeah, 0. S equals 0, right? So the first thing that we're going to write down is s cannot equal 0. Any questions on that? Okay, if that's 0, it becomes undefined. Next thing I want to do is I want to find out what my LCD is. Well, that's pretty simple. What's my lowest common denominator? I only got 1, right? So it's got to be s. Okay, what was our next step? Yeah, multiply both sides by the common denominator. Now, you're going to have s. Okay, this looks a little different in, if you watch her videos, it's going to be a little different than in her video than in mine. When I multiply both sides by s, I'm going to put this in parentheses. Okay, and then she's going to have 6 over s times s. In her notes, she did s times s and s times 5, which is essentially going to be the same thing when I distribute that out. Okay, but over here, we end up eliminating that fraction. Here we go ahead and distribute out the s, and I end up with s squared plus 5s equals 6. Okay? Well, it's from the textbook, so it is evil. Okay. Now, what do I need to do now? Yeah, I get 6 on the other side. What are we creating? We're creating a quadratic. So this becomes minus 6 equals 0. So now we have s squared plus 5s minus 6 equals 0. The next step would be to solve said equation. So when I do that, I want to factor it.
Is that a 5 or an S?
It's both. When I factor this,
55.
S squared plus 55. S plus 6 and S plus 6 and S minus
it's pretty sad Colton's the only one on point right now. So s plus 6 and s minus 1 are factors. Everybody would agree with that? Okay. Equals 0. So I have s equals negative 6 and s equals positive 1. Now, here's the deal. If, okay, we want to go back to our excluded answer. We don't want s to equal 0, so does that come up? That's not an issue, right? So we have two solutions, so now we want to check them real quick. All you got to do to check it is stick it into the equation. So here's our check over here. When I check this, I'm basically going to say, okay, if one of my solutions is negative 6, I do negative 6 plus 5 equals 6 divided by negative 6. Negative 6 plus 5 is negative 1 equals negative 1. That checks out. Do the same thing with, so I know negative 6 is an answer. So do the same thing with 1. So I have 1 plus 5 equals 6 divided by 1. 1 plus 5 is 6 equals 6. That does check out. So these are in fact my solutions. Not cheese, these. Okay. Any questions on this? Okay, next. Click it. Oh, excuse me. It's my fault. I had control still. There you go. Okay, now. Any questions on that previous example? Okay, so let's go into our next example. Now we're going to get a little more difficult. That was not too bad. We're getting a little more difficult. So let's take a look at what we have here. We have 2 divided by y plus 2 minus y divided by 2 minus y equals y squared plus 4 and y squared minus 4. Okay, so let's start changing things that we don't care for. What do we think about 2 plus y squared? 2 divided by y plus 2. Is that okay? Anything I can really do to that? Can I factor that? Can I do anything different to it? Now, what about the next one? Yeah, right now the y is positive, so how do I get that to switch it around and make it the way I want to look? Take out your negative 1. So I'm just going to take this over here real quick and make a little sidebar. So 2 minus y, take out your negative 1. When you take out your negative 1, it becomes y minus 2, right? So then I'm going to bring it back over here. And what is this? So basically I end up with minus y over negative 1 times y minus 2. Okay? What's going to happen here? Okay, so that's going to turn into plus y. So I can get rid of that negative 1, right? So now I'm going to have plus. So now I have 2 divided by y plus 2 plus y divided by y minus 2. Okay? Equals, now we can factor some, right? Is that true? No. Can I factor anything with the y squared plus 4? No, because there's no such thing as sum of squares. So I can't do anything with that, so that's just going to stay y squared plus 4. And then on the bottom now I have difference of squares, which is y plus 2 times y minus 2. Okay? I'm going to go ahead and get rid of this now, since we already understand what we did there. What's our next step? Hang on. No.
Oh, just kidding. Find the LCD.
Okay? Excluded values first, right? So we haven't really done the first step yet. The first step was, for us in this particular answer, was factor and change everything we need to. So the first step is to find your excluded values. So what can y not equal? What's going to create a undefined value? Cannot equal negative 2 or 2. So it can't equal plus or minus 2, right? So it's not going to be able to equal either one of those. Because if it equals negative 2 here, this is going to be undefined. Okay? Cannot, right?
There wasn't a dash through it.
Oh, sorry. Thank you. Cannot equal. You. Okay? And if you equal here positive 2, that's going to create that 0 for the undefined. Okay? Now what's our next step? LCD, which is? Nope. Y plus 2 times y minus 2, right? We take everything that we have, multiply them together. So here we have y plus 2, here we have y minus 2, and then we have y plus 2 times y minus 2. So this covers both of these. So our LCD would be y plus 2 times y minus 2. Okay? Next step, Okay, multiply both sides by the LCD. So now I'm going to have, and I'm not going to skip any steps so that you can see what's happening. And this is kind of why your LCD works. Okay, so I'm going to multiply 2 times y plus 2. Actually, let's do it this way. Let's do this. Y plus 2 times y minus 2, okay, times 2 over y plus 2, plus, now I'm going to do my LCD over here, y plus 2 times y minus 2 times y over y minus 2 equals y squared plus 4 over y plus 2 times y minus 2 times y times y plus 2 times y. I'm off the screen. Yeah, times y plus 2 minus y. Now, what I'm going to do is I'm going to go through and cancel what I can cancel. Okay, that's the purpose of the LCD. So now if you look here, I have a y plus 2 that cancels with that y plus 2. So that leaves me with 2 times y minus 2, which is, without showing you every single step, 2 times y is 2y. 2 times negative 2 is minus 4. Over here I have a y minus 2 that cancels with this y minus 2, leaving me with y times y plus 2, which is, y times y is y squared. 2 times y is 2y. I heard it already. And then over here, everything cancels because that has all the denominators. And like I said, it's off the screen, but your y minus 2 is over here in this region. Okay? It's gone now. I marked it off. So that leaves me with y squared plus 4. Okay? Any questions on that?
So confused. I can't see where you're doing all this.
Okay. So let's do this.
I caught on to the y, 2y minus 4, but after that,
Okay, so I canceled out everything I could cancel out, right? So now I have, what I really have left in my problem, this is step I skip, is 2 times y minus 2, right? Because these things right here cancel. So those are gone. Plus, okay, here, this is gone, and this is gone, so I have my y times y plus 2, so plus y times y plus 2. Here I canceled out this and canceled out this because over here was y plus 2, y minus 2. So all I'm left with is y squared plus 4. So that equals y squared plus 4. Multiplying the LCD through essentially gets rid of our fraction. So now if I go ahead and do the work, 2 times y is 2y. 2 times negative 2 is negative 4. Y times y is y squared. Y times 2 is 2y. Over here, I don't have anything to distribute, so it just comes down as y squared plus 4. Does that help?
I don't say now you got that whole long equation right there.
Are you kidding me?
I'm serious.
What? This equation right here?
Yeah, that. No, above.
This?
Yeah, how'd you get that?
Okay, all of this is still there. I just multiplied my LCD, which was this.
You multiply.
Okay, so here's the deal.
Oh, okay, I get it.
Yeah, here's my LCD. For those of you, especially those of you, because like some of the 5th period might watch some of this too. But here's my LCD right here. And it's over here too. It just kind of went off the screen. But though all that highlighted box is my LCD. If you look here, this is still this. Right? So this is still the same. Okay, and then over here, it's kind of far away now, but over here, that's that. And then that's that, right? So everything's still the same. I just multiplied everything by the LCD, which is in that yellow box. So that's where you get that giant equation from. Okay, and then I proceeded to start canceling things out. So that's where I started doing this. Cancel that out, cancel that out, cancel that out, cancel that, cancel this and that. I canceled all those things by cross-canceling. That's, or whatever you have on top, you have on bottom, you can cancel out. Or reduce it out is another way to look at it. Okay? Yeah, so exactly right. What Lane just said was that what we have left, we just multiply to get the final equation. Let's go on, guys. Alright, so we're not done, obviously. So the next thing we need to do is go ahead and combine like terms. So over here, 2y plus y is 4y. Okay, of course you got your y squared. Throw that in the front. Okay, and then minus 4 here too. Okay, on the other side you still have y squared plus 4. Bring it all together. What happens with your two y squares? They're going to cancel. Because I'm going to subtract y squared from both sides, right? So they'll cancel. Okay? Now, positive and negative 4 are not going to cancel because when I move this positive 4 over, what's going to happen? It's going to be negative. They have to be the same sign on both sides. Okay, so this cancels there, and now I have 4y, okay, minus 8, right? You know what, let me go back a step or two, sorry. And if you already wrote it, it's not a big deal. I went ahead of myself because I was in quadratic mode. We canceled out the quadratics right here, right? Essentially, canceling out your y squared, cancel out the quadratics, which left us with 4y minus 4 equals equals 4, right? 4y minus 4 equals 4. So that's just a simple old what? I mean, it's just a simple what kind of equation? Simple linear. So all I got to do now is solve. So instead of moving that 4 over to get it equal to 0, that's not necessary. Okay, so let's just go and solve from there. Sorry, I got ahead of myself there. So yeah, add 4 to both sides. That's going to cancel. That's going to leave me with, and I'm going to move up here because I'm running out of room, 4y equals 8. Divide both sides by 4. Y equals 2. Okay. Yeah, we got tons of work. What's the problem? Say again?
It cannot equal
Yeah, I like her. It equals the one it can't equal. Okay, it equals the excluded value, right?
It is, but it's not.
Yeah, it equals something, but it doesn't work. So it can't use y equals 2. So we just did all that work, and this is what people think about math. You did all that work for your answer to be simply no solution.
That's life.
Yeah.
That's life.
So, y cannot be 2 because it would create undefined, so my answer is no solution. And it's over here that you can barely see.
I really hope this is long.
Just mark on the whole thing.
Yeah. Okay. Just
No solution. Thanks for playing. SOLUTION. Shut your filthy mouth. Okay.
SOLU pi.
Moving forward, any questions on that? And realistically, and I think Brandon said this, maybe I was wrong, the work is not hard. Okay? As long as you understood like 8.3, I think it was, you know, once you start to rationalize these expressions, it's not that hard.
You don't get tripped up on your,
Yeah, I mean, as long as you understand the LCD, multiplying the LCD through, then you're breaking it down to either a quadratic that you solve by factoring, or you solve by rooftop, which is still factoring, or you solve by quadratic equation, which we're going to see here in a second, and then, or you solve by linear. Now, go ahead and scroll. Yep.
All right.
Okay, here's the deal.
Is that a 9 or an 8?
Yeah, it's a 9. Okay, so let's go ahead and get started on this one. This should be a relatively quick one. So, first thing I want to do is find my excluded values, which are, whoops, t cannot equal 3. My LCD is going to be what?
T minus 3. T minus 3 plus 4.
How about 4 times t minus 3? Okay. Yeah, I think I heard somebody trying to say it.
I don't understand.
You take your terms and multiply them together. So 4 times t minus 3. Oh, that's your understanding? Yeah, you take what you have on the bottom. So I have a t minus 3, and I have a t minus 3, and I have a 4. Okay? You only take one of each. So there's 2 of these, only need 1. And I multiply this by this other thing that's on the bottom. Okay? So now, and we're going to kind of shortcut this a little bit. We're going to multiply by the LCD. Okay? Now, again, if you are not a mental math person, this is fine. We're just doing this for time purposes. If I multiply this through, what is essentially going to happen to this? This is going to cancel, leaving me with what on top? 9 times 4. So I'm going to have 4 times 9 on top equals what? 4 times t minus 4 on top, which is going to be the same thing as what you said, because I'm canceling this out, and then plus what? T minus 3, because 1 times t minus 3 we know is t minus 3, it's going to cancel that out. So basically, all I'm doing is, and this is kind of my little shortcut method, is I take the LCD, and whatever part of the LCD I don't have, I multiply the top. That's it. So that way I don't have to write the whole thing.
You already know the denominators we can cancel.
Right. So that helps you, maybe, maybe not. If you screw that up, go back the long way. Okay? 4 times 9 is 36. Okay? 4 times t times 4 times t, and 4 times negative 4 is 4t minus 16 plus t minus 3, combined like terms. Here I have 4t and t, which is 5t. Then I have negative 16 and negative 3, which is minus 19. What kind of problem do I have? Linear. This makes life easy, so I just solve for t. Add 19 to both sides. I end up with 55 equals 5t. Divide both sides by 5. T equals 11. And again, a good deal would be to check to make sure this works. Just to, be a spoiler here, it works. Okay? And again, I do want to emphasize, because I know I'm not stressing it in class, you should check your work. But just due to time circumstances, we're not. Okay? All right. Scroll on up. Anybody have any questions? All right. Looking at this one here, we're going to come back to it if we have time to. If we don't have time and you work this out, this is going to be a rational with a radical. Okay? It's actually going to be, rational. It's going to have a radical answer in it. So you can end up with the answer, if you want to write the answer down to this problem, if you have the notes, so that you can work it later. The answer is, and I'll write it here, because I'm looking at the time and I'm afraid that we're going to lose time. The answer to this problem is negative 3 plus or minus the square root, 3 square roots of 2 over 2.
Wait.
It's right there. Yeah, that one would have, good. He recognized, because I have this, I'm going to have to go through the quadratic equation on here. That's because this is what you end up with, and that's what you're going to have. So, if we have time to come back and work it, we will. But the other thing is, we need to talk about inequalities. We haven't talked about inequalities yet. Okay? So, scroll up. Solving inequalities isn't much more difficult. It is a little bit longer. Okay? You're still going to find the excluded values. Then you're going to solve the related equation. You're basically going to do everything the same. But then you're going to use the values from step 1 and 2 to divide a number line into regions. Okay? If you have 2 divisions and you have a number line, how many regions are you going to have? 3. Okay? 1 number line. 1 division added, 1 division added. You have 1, 2, 3 regions. Okay? So you have 3 regions. So then you're going to have to test the value from each region to determine which region satisfies the original inequality. That's where the long part comes in, testing the regions. Which is why we emphasize checking in that first part of this unit so that you knew how that works, okay? So, go ahead and scroll up so that I have room. So get rid of the steps. Sorry. You can go back and get that in a minute. Okay, so the first thing I need to do is solve, right? So let's solve this inequality. Anything I need to do, simplify or reduce right away? Factor, anything? No. Okay, so the first thing I want to do is look at my not my LCD. My A cannot equal what? Negative 1. A cannot equal negative 1. Okay, now my LCD is A plus 1. Okay, now let's go ahead and solve. So when I solve this, what's going to happen? The a plus 1 is going to cancel out, leaving me with 7 is greater than, on the other side, 7 times a plus 1. Okay, we skipped steps there, but everybody understand where we got it from. Speak now, forever hold your peace. Moving on. All right. So then I go ahead and distribute there. I have 7 is greater than 7a plus 7. Now what? So solve for a. So subtract 7 from both sides. That cancels, leaving me with 0 is greater than 7a. Divide both sides by 7. So a is less than 0. And actually, a is equal to 0, right? No, we didn't change that. But what we do when you solve an inequality, this should your Algebra 1 teacher should have taught you this, and you may have forgotten. But essentially, when you solve an inequality, you're solving what that value equals. Okay? So a equals 0. But you need everything below 0 to satisfy your inequality. So a equals 0. And the reason that you need to know that is because you are going to use that value of 0, and because you're going to use this, I'm going to put a pin in it. We're going to use this value, and we're going to use this, it looks like 0.1, but it's actually -1. Okay? We're going to use those values, because now we're going to create our number line. Okay, so let's create our number line. So let's do this. Let's blot this guy out for just a second. Don't want anybody to get confused with that. All right, so let's create our number line. So here's our number line. Okay, and all we're going to do is we're going to stick -1 on there and 0, right? So there's the 2 spots on our number line. Now, what I want to do now is I know that a cannot equal -1, right? So you put your open circle there. Okay, why do I not put a closed circle on 0?
It's not less than or equal to.
It's not less than or equal to. It's just less than. So it cannot be 0 either. A is equal to 0 right now. We know that, but we need it to be less than. So it's not part of the actual inequality. So now I have 3 regions. Here's a region, here's a region, and here's a region. I need to test each region. So there's a good number, let's say -2 right here. I'm going to use -2 and test that region. The way I test the region is I'm going to plug it in. So 7 over -2, what's happening here? 7 over -2 plus 1, is that greater than 7? Well, 7 over -2 plus 1 is -7. Is that greater than -7? So no, that doesn't work. Okay, so that's false. If it's false, it's not part of your solution. It doesn't work. So then I go to my next region, and I'm going to use -½ right? It's got to be negative because it's in between. It's less than 0, so we'll use -1/2. So now I go back and I put in 7 over -1/2 plus 1 is greater than 7. What is 7 divided by -1/2 plus 1? 14, right? Just 14. So -1/2 plus 1 is 1/2. 7 divided by 1/2 is 14. So is 14 greater than 7?
I was saying 14 and greater than 7.
Oh, I'm sorry, yeah. And yes, you'd be right. So 14 is greater than 7, so that is a true statement. So that means my solutions are going to be in this region, right here. So then I would highlight right here. Okay, or I could use my sweet highlighting app here, and boom, there's my answer. Okay. Now, I want to go ahead, and you never want, and again, if you're taking a test, tag, star, otherwise, you never want to just stop and say, oh, well, that's the answer. Check the last one, make sure you didn't screw up anything. So here I can put in, yeah, let's put in the easy one. Let's do 1. So mental math, 7 over 1 plus 1. 7 divided by 2 is 3.5. Is it greater than 7? No, it is not greater than 7. So this would be our final answer. Okay, any questions on that? Yes. So here's your homework for esta noche. Whoop, not like that. So page 484, numbers 13 through 19 odd. Okay. Numbers 21 through 31 odd. And 35. Okay, what do we have tomorrow? Vocab quiz. Don't forget. Vocab quiz. Okay. Yeah, so we'll have vocab quiz and Thursday. And a work day. Thursday you will have review. You will review for your test. Friday you have a test. Tomorrow when you come in, I'm going to